Today we're going to start with a panel. We have 6 panelists in all. One, unfortunately, is unable to get our video today. Jazine Varfas, we are having an issue with her video, but we have the other panelists ready to go here, and we're going to turn those cameras on in just a moment. We've got 3 on right now. One thing I'd like to ask you to do is, as you're preparing your questions for the panelists and sending them in, as you write your questions down, if you would please include the name of the panelist you'd like to ask the question to, so it can be directed by me properly to the right panelist. And I think we're ready to go here. Michael?
Okay, can you show the slide presentation, please? All right, well, this panel discussion is actually the first time that we've held panel discussions in the AGIFORS Airline Operations meetings, and this panel discussion actually grew out of some conversations that most of the panelists had when we were at the AGIFORS Symposium last fall here in Seattle. Why have there been no major approaches to disruption management in the last 20 years? And what can we do now? What should we do now? So we've got 6 panelists for you today. We're all going to give a brief presentation regarding our own viewpoint of this issue. And then what I'm really hoping for is that we'll have a very lively discussion with all of you in the audience regarding this topic. Next. So I'm moderating this, and my background is that I've been in the airline industry since 1985, active in AGIFORS since '87. I presented at Rio de Janeiro a presentation on a disruption management system. And I'm a past vice president in operations at LATAM Airlines and Air Jamaica, and I'm currently with Boeing. I've focused over the last 30 years in disruption management and fuel conservation. So next. So what is disruption management? Well, that seems to be the term everybody uses today. Irregular operations, IROPS. This has always been the most complex and costly problem in the airline industry. And when we're talking about disruptions, we're not talking about just a single diversion for maintenance issues or medical issues. I really view it as massive disruptions caused by major weather systems. Different types of weather have different effects. Hurricanes and blizzards cause massive cancellations in advance. Thunderstorms and fog cause diversions at the last minute coming into hub airports especially. All the disruption management systems that seem to have been developed typically focus on recovery, with the exception that in recent years, with major hurricanes and blizzards, airlines have started massive cancellations in advance. So what does disruption cost? A lot of people in a lot of organizations and airlines have been studying the costs for the last 30 plus years. Studies by the FAA, by the US Department of Transportation, Eurocontrol, Boeing, universities, British Airways and American Airlines were some of the early airlines that did comprehensive studies. And there's generally been a consensus that IROPS cost 3 to 5% of total airline operating costs. It's pretty difficult to analyze the costs because some of the costs are on the day of disruption, but a lot of the costs are for the measures that airlines take to prevent the next disruption. And one of the biggest costs of that is lost aircraft utilization and also lost revenue. If people don't get to take their flights, and it's in particular on one airline rather than the whole industry, they get mad and they're not going to fly that airline again for a while, and that's a big cost. So if you have an airline with 100 to 150 tails, it's probably going to cost that airline a total of 100 to 150 million dollars a year. One major airline that studied this very thoroughly has estimated that a single, what they call hub meltdown day, can cost that airline $10 million in disruption costs, just because of the number of flights they have to divert or cancel at the last minute. Next. A little bit on the history of disruption management, and the basic premise for this panel is so what happened? The first system for disruption management was developed by Texas Instruments in Austin, Texas in 1987, and this was installed at Iberia and Thai Airways in 1989. I'm not sure what happened with Thai Airways system, but this Texas Instruments abandoned this technology in 1990 and abandoned airline systems. But Iberia managed to keep their system up and running until 1994, before the technology they were using was too obsolete. This system predicted all the downline effects of delays and cancellations and diversions, and it had a rudimentary methodology to predict illegal crews. It allowed scenario management and cost comparison between scenarios for resolution. Next system was a system developed by American Airlines Advanced Decision Technologies. That was what later was called Sabre in 1990, and that system was the hub slasher, it was called. So how to pick the right 25 to 50% of your flights to cancel when you expect a major blizzard or hurricane coming in tomorrow. Next system was developed in 1995 by a company called Caleb Systems in Austin, Texas, and this was first implemented at Continental Airlines, and this was much more sophisticated than either the TI system or the AADT system. And it evolved over the years, and it's still evolving. The latest iteration is with Slick OR, who's one of our sponsors for this conference. But in my personal opinion, all the developments since 1995 have just been minor improvements over what was done in these three systems. So essentially, in my opinion, in 25 years, there hasn't been a major conceptual advance. And also, all the systems have primarily been, except those which pick flights to cancel, have been focused on repairing systems, repairing the airline, rather than doing anything to mitigate in advance. Most of the major vendors, Boeing, Jeppesen, Sabre, Lufthansa Systems, and many other smaller companies, have some sort of system today, but they all offer downline effects, but with optimizers in the more advanced systems. But I don't think that anybody's doing anything new. All the systems seem to be reactive instead of proactive. So our next speaker is John Paul Clark. I think that probably most everybody in this audience knows John Paul. He's a College of Engineering Dean's Professor in the School of Industrial and Systems Engineering at Georgia Tech. John Paul has really been a shining light in the academic side of the aviation industry for decades now at this point. First at MIT and then later at Georgia Tech, and he was also senior executive at UTC for the last couple of years. So JP.
Thank you, Mike. You're way too kind.
Next, Gary.
So I am happy to be back in the academic ranks, and when posed with this question of, why haven't we made progress, and what can we do, I thought less about trying to put together here's a specific solution, and thought I should step back a little bit and put a philosophical spin on the whole thing, which is part of why operations is such a unique challenge in aviation ORs, because airline operations are stochastic. Much of everything else assumes that there are very deterministic behaviors and there are deterministic models, and you're trying to reduce pay and credit, or you're trying to basically minimize spill from a known demand model. All of the things that most of the things that we do in other parts of aviation OR are deterministic, or at least perceived to be deterministic. And so we cannot blindly assume everything goes to plan, because there really are uncertainties. And that's one of the problems in aviation or in operations, is that if we make that assumption, you get burnt. And stochastic things are difficult to model and to simulate. We had the curse of dimensionality coming your way when you talk about how you model and simulate stochasticity. That's one of the big things with us, that we really can't see that. Next bullet, please. And the thing is that there's so many little nuances. I can think back to the days when we're trying to build a tool like means, for example. One small change in the behavior of one airport can have impacts all over the entire network, and being able to understand that model is very difficult. And finally, the big part of the challenge, once you get through the math, is humans have a hard time dealing with uncertainty and stochasticity. In fact, decision makers our tendency is to basically just put our head in the sand and cut off the on and say we got certainty, right? Because that's basically, we as beings like certainty, and we give a greater weighting to predicted benefits that appear to be certain than benefits that are known to be uncertain. And so that's something that we have to work on. So with every challenge comes an opportunity. And like I said, I'm not going to give a specific result. I'm going to talk about philosophically. We have two sets of models. The physics and logic-based models provide insight into causality or causation. I prefer causality. Some people say causation. And you might say F equal ma is a very well-known physics-based model. But how was this developed? Well, the reason was we had very controlled experiments. Next bullet, please. And where you can actually independently measure the inputs and the outputs. And so, there's no such thing as really, unless you see somebody push somebody else or something push something else, it's hard to show causality. In fact, I always joke in physics we talk about up quarks and down quarks and strange. And when is the last time you saw a quark roll by and you said hello? I mean, we have done experiments and we have a theory, and our results agree with our theory, and we postulate that that is the basically physical thing that is happening. And so physical models are really based on preponderance of evidence, but evidence in control examined. On the other side, we have a great birth in machine learning and other types of AI techniques and data analytics. And these provide insights into correlations. It's hard to prove causality because you're doing lots of data, but you need a lot of data to calibrate them. But the good thing about that side is that there's growing use and acceptance in decision-making at all levels. I mean, so somehow CEOs and C-suite individuals are way more accepting of what a machine learning regression model tells them than a physical model with built on experience. And I don't know why. That's a debate maybe for a social hour. But the fact of the matter is, it's growing in importance, and it offers some useful tools. It offers ways to gain insights into massive amounts of data where we cannot do what we do on the physical side, to have controlled environments with independently measures inputs and outputs. So the punchline is, the next slide, which is, from my view, hybrid analytics is the optimum combination. And this is where I think from an operations side, we need to harness both the physical models, the things that we know are happening. I mean, people have to drive in traffic, to turn up at work if you call them out of a reserve crew to come to the airport. And we know, that the traffic is a stochastic. We can use machine learning models to figure out, what the distribution is for travel time as a function of time of day and all of those things. Of course, they'll all be different now because we have no prior data with post-COVID. But anyway, the bottom line, again, that's why the hybrid analytics works really well. You can calibrate physical models, and you can use the data analytics to develop new physical models, and the physical models to tune how you do your data analytics. So hybrid analytics is, for me, the way to go. And with that, I think I've taken my 2 minutes that's been allotted, and I'll turn it over to Ira.
Hello, everybody. I've been involved with irregular ops since my first job at American back in the early '80s, and it's been a key theme of everything I've done as part of my career in both operations and IT. So on irregular ops, I'm going to take a little bit of a contrarian view. Which is actually, I'm going to be echoing a lot of the things John Paul said a minute ago. Can we have the next slide? I think the key issue that I'd like to talk about is about the costs. Now, Mike presented some costs, and I think those are fine, but they are long-term average costs, and in order to get a solution or a better recovery from a irregular ops problem, we need to be able to quantify the costs for the particular incident we're worried about. And the components involve revenue lost, direct costs incurred. So if you cancel a flight, you save the fuel, for example, and you may also save some other costs. Delayed flights are a problem. 5 minutes is much better than an hour and a half, obviously. But even then, there's some variance in how much the delay is costing you at a particular time. If the delay is at the end of the day, say at 10 p.m., it may not be very costly. There are also misconnections and the last one I'd like to talk about, I call it the elephant in the room, is lost future business. So when customers are disrupted, they're not getting to where they want to be when they want to be, and I know of one fairly rigorous study done by an Asia Pacific airline that looked at the cost of lost future business. They looked at what percentage of which passengers were disrupted based on their frequent flyer records, and then measured the impact on their future business and found that it was quite significant. And the reason it's the elephant in the room is because it's also dominant. So people have a tendency when they have costs, large costs that are hard to measure, they don't measure them at all. I think that's the wrong answer. The right answer is make your best guess. Best guess is way better than ignoring it, because if you ignore it, you're saying it's zero, and zero is undoubtedly the wrong number. So if you had true costs, you'd be able in position to say to your chief financial officer or anybody, you basically make a business case. If we'd done Y instead of X, we would have saved real money and show it. Or you make the case for some sort of IT system. It will cost us X dollars, and we can build a system that will save Y annually, and then it's a straightforward financial analysis. The financial people who basically run the airlines are, my experience is pretty agnostic about cost. So if you're going to show them something that you can get back, they'll take an interest, and if they take an interest, then you have some chance of getting funded and going along with that. So there are a number of solutions that are out there now, as Mike said, that they seem to work pretty well, but they're not being adopted, and because they can't solve everything, and they're also the problem. I call them big bang solutions because they're subject to being made irrelevant by subsequent events, which can occur very quickly in a fast-moving irregular op situation. Let's have the next slide. So here's my suggested solution: is quantify the costs, as I mentioned. If you have costs you can depend on that are valid for the particular event that you're looking at, or a future event that whose parameters actually describe it. This gets along with what John Paul said. Let's have a function that we can, an F equals MA equivalent, that we can base our decisions on. And another element that needs to go in there is, what is the importance of the problem, or pieces of the problem, in terms of importance and impact and urgency. So there are important problems that don't need to be solved for a couple of hours, and there are there's the flip side of that. There are unimportant problems that need to be solved. You need a resolution right away. So, and that can be by having the costs and some element of the time horizon where the decision must be made. I think those are the keys to getting toward IT solutions that will help the ops controllers, as well as save money for the airline, and begin the virtuous cycle of continuous improvement, which will eventually, maybe sometime in the not too distant future, we'll be able to declare victory on this issue. That's all I got. Back to you, Mike.
So our next speaker. Yes. Our next speaker is Michael Clark, who is most famous for having run this organization for 12 years, much better than I think we've been doing since him. Michael, you want to talk a little bit about your background?
Sure. Well, thanks, Mike. I had the opportunity to meet Mike actually in 1988, I think, in Houston. Yeah, I think that's when it was, or whenever the study group was in Houston, or actually it may have been 1998. That's what it is. I'm getting too old. But my co office mate at the time convinced me to get involved in AGIFORS. So it was actually 20 years that I had the privilege of running the conference and taking it around the world. And I decided that it was time to leave it in the capable hands of Judith and Michael, and they've been doing a great job despite what Michael is trying to say. But I've really worked in this area for the last 28 years of disruption management. I was actually motivated by an experience that I had going from Boston to South Florida for spring break. And it really opened my eyes to see how decisions were made in airlines on the day of operations. And over the past couple of decades, I really spent a lot of time working on the problem, ranging from developing algorithms to product management to sales engineering. And the irony of the situation, it all motivated from me trying to get to spring break and missing a few days of spring break. So the key thing in life is to work on stuff that you're passionate about, because your inspiration will give you the necessary focus and vigor to actually work on a specific topic. So as you guys may have noticed, there's somebody else on the panel that looks like me. Whenever we have this conference, at our ultra inclusive conferences, I always tell people it's not the adult beverages that you're drinking. There are actually two of us that are actually here. So now you can physically see that there are two of us in existence. And we do work on similar things, but we come at it from a different angle, I guess is the best way to put it. So we're both originally from Jamaica, and besides working, I love to travel and I like to spend time with close family and friends. So I guess that's a good summary to it. So let's move to the next slide. So we've touched a lot on what disruption management is, but one of the things that I like to say is that I've come to realize that disruption management is really an art, and it's really beyond just applying smart ideas and developing advanced algorithms to solve a problem. And as John Paul mentioned, and Ira and everyone else before, the majority of all of our strategic and tactical planning decisions, assume ideal blue skies and everything's going to work perfectly, and we're going to make as much money as possible with the resources that we have. And that almost hardly happens in practice. And although a lot of airlines use advanced optimization techniques for planning, and there is the existence of disruption management tools, a large percentage of airlines still rely on manual decision making for disruption management. And even those who have actually decided to acquire, buy, deploy an advanced optimization based solution for disruption management, they hardly use it or they don't trust it. And that's based on my experiences. That's obviously can be inferred from presentations from everyone that has talked about disruption management over the years. And I think even the next presentation that we'll have from Sebastian will touch a little bit as a follow-up to the conversation he had about that in Paris last year. And one of the things that I've also found that's interesting is that all of these different schedules are tightly coupled. The aircraft rotation, the crew assignments, the passenger itineraries, and they're all very susceptible to different types of disruptions. So if a crew member calls in sick or there's a strike, it's going to impact the network. If there are several aircraft broken, it's going to impact the network. If there's an external factor such as weather, it will impact the network. If passengers don't show up, we're still going to fly and we're going to still keep their money. I mean, things may change post-COVID, but traditionally airlines would still keep their money. So it didn't really matter that much if the passenger didn't show up. But the key thing is that all of these decisions about these different resources are made independently of each other in the planning process. And they have such close impact of each other in the actual operations process. So how are we actually really planning and executing for disruption? So yes, over the years, we've been able to leverage a lot of advances in compute time to be able to develop algorithms that produce solutions that partially, I use the word, solve the problem. We can generate a solution. Some of my colleagues talked yesterday about some of the advances that we've done. Amadeus talked about stuff on Monday about what they're doing with Qantas. There's a lot of good, solid solutions out there. But after spending almost 3 decades working on this and developing something that works, I'm starting to think to myself, are we really solving the right problem? So next slide, please. So, in recent years, there's been a lot of interests and excitement about using artificial intelligence and machine learning to predict what will happen. And I am 100% behind that idea. And there's no shortage of data in the airline business. In an operations control system, there's one of the biggest headaches the IT department has is how to purge the database so it doesn't blow up, because there's no shortage of data. And even with the new aircraft that are coming on board, there's a lot of new additional data that can be obtained while in flight. And I think everyone will agree the primary use of data today is for alerting and managing by exception. There is an opportunity for us then to say, we have all this rich data, especially in North America. We have over 40 years of operational data from the ASQP data. We have the ECODA database in Europe with rich operational data from Eurocontrol for several years. And there are a lot of current work being done on predictive recovery. So we're at the stage now where we have reactive recovery. Something happens and we run something to fix it. We're now saying we want to do predictive recovery or predictive analytics. So we predict that I'm sitting in South Florida right now, looking out the window. It's kind of cloudy as it is in Germany as well as France. So most likely, I'm in South Florida. It's most likely we're going to have thunderstorms this afternoon. It's a given, right? We can predict that it will happen. So at 10 a.m., I'm going to decide that I'm going to make a change to the flight schedule later on today. I live in South Florida, and I've put up shutters for hurricanes that never come by. And I've not put up shutters and have heavier rain than during a hurricane. So, to all due respect to the meteorologists, it's hard to predict the weather. But we have enough operational data to predict disruptions in the future. So there's an opportunity to then say predictive analytics is a solution. And last summer, I had the opportunity to sit with a bunch of executives from some of the world leading airlines and says, we are at the cusp from an industrial standpoint, and specifically from where I work, we're at the cusp of being able to predict that there's going to be a disruption in 4 hours. And we have these optimization tools that can recover, quote unquote, the solution before the disruption happens. Who is willing to actually run it before the disruption happens and have that confidence? And if there were 10 CIOs in the room, only one said, yes, I would do it. The other one, everyone else said, I still wanted to wait and see what will happen. So is predictive analytics and recovery really where we want to go? That's a big question. I think we need to go there. But what I think we need to do is that as an industry, we really need to focus and pivot to say, in the first place, have we designed this jigsaw puzzle so that it can be recovered? So it's not a matter of just saying, I want to predict the disruption. It's a matter of how can I use all of this operational data to go all the way back to the start of the design process and say, have we actually designed the flight schedule so that it's robust, less susceptible to disruptions? And even if it's disrupted, can I recover the flight schedule in an efficient way? So that's what I think we really need to focus our energies on, especially for the academics out there, to say, how are we even designing the schedule so that we can recover it effectively and efficiently? Because yes, we have some great tools, and we've been able to, pull a lot of our hair or have a lot of gray hair develop on how to make it run faster. But we're maybe fundamentally solving the wrong problem. So there needs to be, obviously, I've worked in the airline industry enough to know that it's not just a matter of saying, okay, we can design a schedule that's totally flexible. We need to have obviously greater flexibility in the redeployment of resources. That may be easier from an aircraft standpoint, but we also have to look at the crew, regulations, ground resource support that is needed for this to happen. And then ultimately, another area that I think that we need to focus on is really being able to have the end user have a better understanding of the benefits of why we're doing something. I mean, we have that challenge in reactive recovery. We're definitely going to have that challenge in proactive recovery, and it's going to be even more challenging in being able to design robust schedules. But those are the areas that I think we need to start thinking about. We've done, as Mike said, for the last 30 plus years, we've worked on reactive recovery. We have great tools out there in the marketplace, and I believe in them. But there's an opportunity for us to go even further, because as technology has evolved, it has created, we've gotten the improvements in compute time. The emerging technologies that are out there in terms of machine learning and AI are going to fundamentally change what we can do with the data. But the question is, how do you use the data to really change the paradigm? So that's kind of my thoughts on disruption management for today.
Okay, next, Gary. Our next presenter and panelist is Jacine Varfus. Unfortunately, her camera is not available this morning. But Jacine has been working in the whole area of OCC decision support systems, both as a provider and as an airline person. So Jacine, you want to talk a little bit about yourself?
Yeah, sure. Thanks for everybody listening to the panel and giving us the opportunity to exchange a little bit. And well, my background is in ground handling, so I have a background in turnaround management, and then moved on to Lufthansa Consulting, where I had a long time in doing concepts for HCC, OCC, etc. And we did work with quite a number of airlines. And then I'm at the customer, Aeroflot, who said, wonderful, now you're going to do what you're recommending. And that was quite an experience. And I can tell you that the reality, and this is definitely going into our area of disruption management, the life of implementing a system, making it work, is very much different from doing concepts. And I think I've learned a lot, and I hope we changed a lot. And Aeroflot was definitely one of the clients I've been working for, or being part of the airline, who really changed everything. I have worked for airlines who have not changed anything over the 20 years, when we look at the picture of 20 years. And Aeroflot did change a lot. We did the OCC systems, we did flight planning systems, resource management for the airport system, hub control system, etc. It was a massive job change. After that, I did Airbus, a subsidiary of Airbus, and their marketing manager now. I'm not speaking French, this race needs to improve. And I'm responsible for building up our future MRO ways, which means we are currently looking at different simulation tools. And APSIS mainly focuses on risk management and simulation, safety in design and production, and we are also looking after cybersecurity issues for customers. And we can move over to the presentation now. If you could show the next slide, please, Gary. Okay, talking about disruption management. Coming from the consulting background, I really love benchmarks, and I think we cannot compare ourselves with the dot-coms, with Facebook, etc. So let's look at the car industry. I think if you look back, I would say the glass is half full instead of half empty. We have really changed quite a bit. We have changed the products. We have really good disruption management solutions. So we really have quite a good car on the road by now. However, we still drive cars with fuel. We still drive on roads. And I think this is the same for us in the industry we are in. We still are bound to our environment we are currently in. We might look into the future, what could be better and what is our vision. However, we are still bound in what we have in our hands currently. And coming back to the car industry, this is the road, this is the car, this is the fuel. We have changed a lot, I would say, over the 20 years also in culture. You might have wondered what this nice little thing is knitted in the colors. and what the dog is. This was in the 80s for Audi, the thing you had in your car, which means below this wonderful colored thing, this is toilet paper, and the dog moves the head. So imagine this type of change in attitude, culture, processes. This we have done as well, not only the car industry. We also do hackathons now, not on sustainability and mobility contests, but for example, Swiss has done a hackathon last year on rotation delays. So we are getting there. Where we are very much different, I would say, than the car industry is you cannot select your solution. You cannot go and say, oh, look at the ops control solution, flight planning solution, and I take the 30,000 one instead of the 40,000 one. And I just take this in this color code. We have a way more complex environment, and taking a system out is a very dangerous thing. And I know quite a few airlines which are really scared of doing so. And we have an industry which is maybe not having so many changes. If you think about the last 20 years, how many cars have you owned or bought or driven? Whereas in our industry, you just change not that often. And again, I know airlines who have not changed their operations control solution for the past 20 years. And we do also have ways more suppliers and vendors. If you look at how many motor vehicles have been sold last year and produced, it's only 14 companies who are sharing the revenue. And if you go to the next slide, I would like to show and share with you a little bit how I see the development over the years. I would say in the 80s, we had really silo solutions, not only as solving solutions, but also as departments. And we have sent CETA messages backwards and forwards or used the phone. I would say in 2000 plus, we have really established what I would say an industry standard in terms of operations control, maintenance control, collaborative decision making between the hub control center and the airport control center. And we have started to integrate our silos and make it more communicative between the silos. I would say I met airlines which had about 200 plus systems which had to be connected and integrated. We have done a lot in terms of standardization of data, interfacing, ESB standards, and we now know what happens. We have the situational awareness. What is maybe new in 2005 was that we had business intelligence giving us KPIs and indications to really know where we are. However, we did not really look ahead and knowing what will happen in the future. And this comes back to what Michael has been saying. We really need to go into this predictive mode. And I would say in the last years, when you talk about an integration operations control center, you have more and more airlines having analytic teams in the background. If I remember well, I think American has a team of 30 people doing analytics in data. This makes a major difference to know what will happen and know why it will happen. Airlines use cost index operations to tell the aircraft to fly faster if you have missed connections, etc., or to fly cheaper and use not so much fuel. You have airlines who have in-flight mission control, which means you not only have the black box when you hand over the flight line, but you support the cockpit during the flight and make sure that you have reroutings due to weather, etc. Australia was pretty good in introducing meteorological collaborative decision making, which I think is very good in predicting weather situation and agreeing together who is going to cancel what flights in what manner. It's really worth to have a look at what they have been doing down under. And I would say we are now in the IOCC of an analytics age. We know now what will happen. We are now moving forward to predictive analytics, and I would say we could really have a look, and this is where I would say the glass is half empty, and I agree with the other panelists before. We have not done much on solution finding. However, if you look at maintenance, there is a lot going on in terms of predictive maintenance. The idea really is to have based on the condition of the failure to really predict when this failure will happen. And they're pretty good at it at the moment. And I believe that we could learn a lot of operations from maintenance in this regard. Going ahead, which means the target is 0 ARG. We know the maintenance cost. This goes down also with the irregularity cost. Knowing these type of costs is key to all your decisions, which means we need to go further into not gathering cost data and knowing approximately what a cancellation costs. We really need to know what type of cancellation of flight is really the one which has the most impact. So in this regard, I think we have a few airlines already working on that. However, in general, I would really recommend that we go further with that. That would be the thing we need to change. We need to work more on the optimizers and simulation solutions, having the possibility of having changing real-time data applicable to all of the situations we are predicting, and to have decision support solutions in terms of prescriptive maintenance. And this brings us back to analytic platforms. One of the drivers will be definitely machine learning, artificial intelligence, and digital twins. And if we move over to the next slide, I would like to give you maybe a vision of what we could do. As I mentioned before, the car industry has 14 big players sharing the revenue. I would say we have ways more. We have traditional operations, system solution provider, and I have not listed all of them. I hope that I do not forget the ones who are on the panel. And we have also on the maintenance side a lot of players for predictive maintenance. You have Airbus with Skywise, you have Boeing with analytics, you have Lufthansa Technik with Aviatar, you even have SAP, IBM, GE, Honeywell, and PricewaterhouseCoopers working on predictive maintenance. And nobody works on operations, disruption management prediction. I would just say with COVID having a really bad situation for our industry, why not have people working more cooperatively together? Why not join forces and develop predictors which will help us all and deploy them in the different traditional systems any airline has in place? And what is also very important, what I have seen so far is, do we have the skill set for these type of analytics? Do we have the math, statistics, and computer programming background in the OCC to really deal and do the decisions based on what people will get out of the analytics and use these analytics tools? This needs a lot of change in corporation. And one of the things during the COVID shutdown and lockdown for all of us came from the World Economic Forum. They have an action platform. And one of the things World Economic Forum recommended is that we do things collectively, that business communities should work collectively. And I really believe that some of the analytic skills we have here in place and in the community, if we would do some crowdsourcing and collaborate on defining algorithms and simulation tools, I'm pretty sure we can apply them for a number of airlines together. And we should do this jointly and not everybody separately. That would really bring down the cost as well as the applicability. So that would be my vote for collaboration and for the further discussions. And I give back to you, Mike.
Thank you, Justine. Our last panelist is Anna Sauer from Lufthansa Consulting, who's also worked on both sides of the fence here as an airline person and as a decision support provider. Anna, you want to talk about yourself a little bit?
Yes, of course. Thank you. Good morning, good afternoon, and good evening, everybody all over the world. I'm currently working for Lufthansa Consulting as a senior consultant, specializing in ground operations and passenger care. But I got hitched on airline business 10 years ago, a little bit younger than you are. And since then in it and absolutely passionate about it, especially when it comes to disruption handling. among other projects I did in the past, I was very focused on operational KPIs and reports, trying to get predictive KPIs, improving punctuality and process performance, especially concerning disruption handling according to the EU regulation 261, and implementing a couple of tools, self-service tools and helpful disruption handling tools in ground operations for different airlines. And that's where my thoughts are coming from, that I want to introduce to you in the next minutes. So could you please switch to the next slide? The question, why do we need disruption management? Of course, everybody agrees. We all know it's not an exception. It's more of the daily operations. And the task is simply to efficiently handle irregular operations. But what is the actual goal that we have in disruption management? Ideally, a more punctual and resilient and stable operations, which minimizes the impact of unforeseen disruptions and avoids the predictable ones, which then comes to the questions, why do we really need that? And that comes back down to saving costs from disruptions and achieving a higher revenue in general. So ultimately, for me, in the end, all of this comes down to costs and passengers. And I think we should put that a little bit stronger in focus in general, that it is in the end about money and about the passengers giving us the revenue. So some thoughts about the current status quo and the challenges behind it. Currently, the disruption handling systems are mainly based on reactive decision making, as we've heard before from the previous speakers as well. And we found out in a study from Lufthansa Consulting that some of you might have heard about yesterday from my colleague Martin Settlecek, that only 6% of airlines at the moment use tools with artificial intelligence for decision making in the operations center. So this number is still very low, even though the technology is there already. So when you look at the reasons behind this, why there are so many difficulties in having more successful proactive disruption handlings in place, in my opinions, in my past project, I found three main reasons. One is highly interlinked complex processes that meet silo thinking. We've heard about silo thinking before already. Often the decision making is separated. It's especially in the operations department already separated. So for example, rebooking options for a flight are only checked after the flight is cancelled by the ground handling people afterwards. The other one is the up-to-date technology that's already there. We've heard about it. We've seen already great tools, great technologies developed by some companies. It's there, but it meets outdated IT infrastructure and legacy systems in the companies. So for example, there are older data warehouse systems or existing legacy systems, not only in the operations department, but also before and upstream and downstream processes where they store the essential data that we need for our decision making, which leads then especially to missing data, bad data quality, especially when it comes to predictive KPIs. And if you can't determine, for example, how punctual your passengers at the end of their journey were, how do you want to decide on what's the best decision on disruption handling and how high are your costs actually, depending on the different decisions, if you can't even tell the percentage of customers that end up at the end of their journey on time. And third point, the theoretical planning that meets the reality. We all know when putting together schedules, the focus is on efficient revenue generation under ideal conditions. And these decisions are usually very data-driven. But once the disruption happens, the focus immediately shifts over to experience-based decisions by people. And these decisions then nullify the originally planned schedule benefits. And that actually brings us to the question what we can do now and how we can deal with that better with these challenges to actually implement more proactive decision making. So to the next slide, please. In my opinion, my learnings from the past projects that I've been on where we tried this was that you have to start with getting the basics right. Only with getting the basics right, you can enable the switch from a reactive management to a more proactive steering. So it's not enough to just develop a new system. You also need to operate this new system in the existing environment, and you need the data from other systems as the input. So solve data quality issues first and make missing data available to enable predictive steering. For example, you need to match these passenger booking data with the flown data from the flights for passenger punctuality, and that live, that's very difficult at the moment. So that is definitely a challenge to tackle. Also, you need to update the IT infrastructure to support up-to-date technology. Often databases and systems are not able to supply the live data that you need at the moment. So current systems rely on the data they have, but there would be so much more available if you can make the other systems, also the system of your system partners, providers, etc., at the end of the chain available. The second point, the big picture. You always need to look at the big picture and focus on the target. So it's important to integrate all upstream and downstream departments in this topic. It's important to consider their needs in the new decision making, but also in the development of new systems. It's important to include experts from other areas, especially those planning the schedule, finance people, and those living with the consequences of disruption. For example, the ground handling companies that actually deal with a lot of the outcome of this decision making that we have at the moment. It's also important to keep the focus on cost avoidance and revenue generation. So minimizing the total cost from disruptions can maybe sometimes also mean less automation in some cases. So we have to look at what is actually fulfilling our final goal of reducing costs in the end. So maybe sometimes instead of coming back to the passenger example, immediately rebooking all the passengers and maybe then making them to rebook themselves again, the better option would be to not go on full automation and instead giving them self-service rebooking options. So half automizing the process instead. And it's also important to look at sustainable implementation and day-to-day execution. So decisions, in my opinion, are only as good as their execution in the end. So if you make a decision to prevent a disruption, but you have no system in place to communicate that to everybody, to the passengers, to the ground handlers, etc., or this communication is too late, it lowers the value of the new system as well. Just an example to come back to Gezine's car example. If you build with your system an Autobahn and you have this amazing Porsche to drive on this Autobahn with 130 miles per hour, that is great and it's a great system. The problem is if you then hand over to the next department or to your service providers that you use, and they only build a field path that's used for agricultural vehicles, your Porsche will have troubles running there. So it's important to make sure that all your systems interact with these as well and keep them in mind. So everything you create needs to be implementable in the end as well. So I think that's a big challenge with the existing solutions that are there already, because I absolutely agree, we have a lot of great solutions at the moment already. And in the end, from my point of view, it helped to start small and then build up. So not one tool to solve all problems immediately, but individual interconnected modules and systems. So consider what customization is really essential and where standardization might be more efficient. And always keep in mind the interfaces and the data exchange with the existing systems there and the future systems to get it running smoothly so that the Porsche can actually drive through all the way and is not hitting this field path in the end, diminishing all the effort we did before. So that sums up basically my view on the disruption management. So back to you, Michael.
Okay, we're going to field questions now. Remember, please direct your questions to the specific panelist, and remember that that black square on your screen represents Jacine, who is also with us, even though her camera doesn't work. Mr. Facilitator, could you please?
Alrighty, folks. The first question this morning, I keep referring to morning because of my own time zone. I apologize for that. Is directed to Ira. What impact does the type of airline have on funding or adopting IROPS solutions?
Well, the size of the airline, I guess, and the type of business, yeah, would have an effect. And just a quick example from when I was at Polar Air Cargo, we judged that our needs were about 75% of FedEx, but we were about 10% as big. So that's an advantage that large airlines have, is they can make, because they have more, their investments affect a larger economic entity. Their returns tend to be higher. So I would say for a smaller carrier, or one that does not have a traditional model of planning, of publishing schedules and then selling tickets against those schedules. You want to see where are the issues that you're facing in IROPS, and direct your solutions toward addressing those specific things, and don't try to do the, in fact, it applies to anybody, but especially for a smaller carrier, is try to focus on the things that are most important to your operation, and not on the picture of how do you avoid everything, every possible contingency for every situation.
The next question is for Michael Clark. Airlines know when spring break is happening. Why not prepare for the days when you know when you have flights full of party animals from MIT?
Well, I mean, in that particular year, it was 19. I may not age myself, but it was a year when it was one of the worst nor'easters in history, and it was at the cusp of Caleb deploying even the initial solutions at Continental back then, and there are other airline names in the skies that aren't with us today. But the real challenge was that even then, airlines weren't even in a position to plan for it, because that I don't remember the exact year, but that nor'easter was so, I think it may have been 1993. It may have been my first year of graduate school. But that nor'easter was so bad that there was nothing that any airline could do. And airlines had traditionally been, and as the panelists have highlighted, there's still a strong reliance on experience, because even if they planned ahead, and aircraft resources are not cheap, right? So you can't say I have an extra plane sitting around, A300. Let's age yourself back then. Most likely that was the wide body aircraft available for Eastern Airlines or whatever it was. But the issue really was that the resources that we are talking about are so expensive that even if you pre-plan for it, you're still going to have a bunch of rowdy MIT, Harvard, Northeastern, BU students wanting to get to South Florida. As you notice, they still wanted to come down to South Florida when we had COVID, so it didn't really matter. But I mean, back then, people wanted to get to spring break. I mean, if you've had the luxury of living in Boston for a winter, or in a cold environment for a winter, the idea of having to be able to get out of town for spring break is very appealing, right? And I guess in retrospect, it would have just been easier to just hit the road and drive down to Florida and forget about the airline. But they just weren't in a position to plan for it, I guess, because of resource constraints and just the cost of resources.
The next question is for Ira and for Michael. The asker says, in my opinion, to develop a proactive IROP system that really works, you need to include all the stakeholders involved, i.e. the airlines, airports, ATC, at least 3, representing their interests and objectives in the system, and not only for one airline. And the question is, do you think the airline industry is ready to share the data and information necessary for this kind of collaboration that necessarily has to have a high degree of automation? Ira?
Well, I think you have a number of stakeholders that have a part. my mind keeps coming back to the joke told by one of the leading ops controllers in my day, who said, "My job is to come up with a solution that nobody likes, everybody can live with." I think that's one way of saying you have to balance the needs of the different stakeholders and try to come up with something that at least works for everybody, even though some entities will do better than others. And this is where I think it's also important to, again, bring the finance function into the game, have them evaluate what the various cost trade-offs are. My experience is they're good at that, and they need some help from the operations people to actually tell them what's going on. So that's something that could help to make that trade-off.
Hey, Gary, was that for Irrgang or me?
I believe that was for you, Michael. It didn't say specifically.
Okay, well, I mean, I can share some thoughts. I mean, the question, just to reiterate the question, was how can we have effective disruption management if there's not better collaboration between airlines, airport agencies, and air traffic control authorities? And you know, many airlines that we you know, outside of the ultra low cost carriers and low cost carriers and the boutique carriers, for lack of a better term, most other established airlines are in an alliance. And from my years of experience and observations, I actually think that there is better collaboration between, for lack of a better word, the dominant carrier at a hub airport and the airport authority and air traffic control than they have with their quote unquote alliance partners. So, you know, there is a lot of work that has been done in ACDM in Europe, you know, through the CESAR program and various programs, and in North America, and even in other parts of the world, like, you know, working with customers in Australia as well as in Asia and as in China. There is collaboration between the airline, especially if it's a dominant airline at a hub airport, and the ATC and the airport authority. Because in some cases, the airline controls their gates. But the collaboration is definitely there with air traffic control. What I see is a lack of coordination between the airlines within an alliance. And what I mean by that is that, you know, your friend today may be your enemy tomorrow. If I'm old enough to know that British Airways has gone full circle in terms of their alliance partners. You know, they used to partner with US Airways, United, and now with American, which is now US Airways. So they've kind of come full circle. But one of the things that airlines are resistant to share is the most important part of the equation, to Ira's point, which is the revenue. Because yes, you're my alliance partner, but each airline, and I'm not picking an American and BA, and it's true in Star Alliance, each airline sees their passenger as their passenger. It is not the alliance passenger. And until that mindset changes, you'll never see the type of coordination that's needed between airlines. I have never seen American Airlines call up British Airways and say, can you hold these 5 flights to Nice, Marseille, and Paris because I'm running late into Heathrow? They're like, we'll put them on our next flight. But it may be more cost advantageous for them to hold those 5 flights. But I have never seen that happen. I mean, I could be corrected, but I mean, so that's what I mean. So I think the coordination is there between airlines and ATC, airlines and airports. What I see missing is the collaboration between airlines, even within quote unquote strong alliances.
Actually, I have a slightly different view of that. I agree with what Ira and Michael are saying regarding the operations coordination, but in fact, regarding revenue coordination, I think that that's something that's been around for decades and following since I believe sometime in the 70s or perhaps early 80s. All the U.S. carriers decided that they wanted to come up with a common way to pass passengers to each other in a major hub disruption, and they came up with a concept called FIMS, which is a way of passing passengers from one airline to another without forking over a lot of money in the process. So an airline would collect whatever it could from an individual passenger, but then had a negotiated price to pay the other airlines in the hub that could reaccommodate. This worked very well in the US, but no such thing existed in the rest of the world. And just to give you an example, when I ran the operations of Air Jamaica, when we would have to cancel a flight from London to Jamaica, what I had to do is we would have collected perhaps $5,000 round trip first class from Kingston to London and back from a passenger. But when we canceled their return flight in London, my only option was to pay $14,000 for a one-way ticket from London to New York on British Airways, and then bring them back to Jamaica from New York. Now, what happened with the advent of the Star Alliance and One World and SkyTeam is that between all of those carriers, what they've done is they've implemented the American FIMS concept within their alliance members. So if a different airline had, in one of those alliances, had a similar event to my Air Jamaica cancellations, they would only have to pay a negotiated alliance price for that first class accommodation.
The next question is also for Michael Irrgang. If we take one of the simplest data, which is, in my opinion, weather, we have forecasts. We could use past data to establish probability of certain weather development. Yet even this is rarely offered by providers. Question is why? Should they push end users more to accept advanced technologies by showing them advantages?
This actually is something that Tim Nisnik of American Airlines and I have discussed a lot over the years, and in fact he made a presentation a couple of years ago about this. And the fundamental issue is that you, as Michael Clark was saying earlier, he knows there's going to be thunderstorms at Miami this afternoon, where he is sitting right now. But precisely at what time is it going to be? It makes an enormous amount of difference if it's going to be at 2:35 or 2:55 or 3:10 that thunderstorm causes Miami Airport to be closed for all the inbound aircraft. And what airlines have always had this enormous fear of is if they take proactive action regarding the diversions that might occur, what if they are wrong? And as I recall from one of Tim's presentations, he talked about some cases where American could have 100 diversions, or they could have 0 diversions, just by a difference of a few minutes as to when that thunderstorm closes DFW Airport.
The next question is directed to Anna Sauer. Why do you think airlines still didn't make better progress on disruption cost identification? And is the problem here really a technology?
I'm absolutely convinced the problem is not technology. I think the technology would be there to do it, but the complexity of it and the different data sources and the type of data to bring that together is really complex and difficult. And again, with airlines, we're meeting here the silo thinking problem, that you might have the data available in another department, but you might not even know that it's there. So we recently developed a passenger punctuality KPI with an airline, where we tried to find out how punctual the all over customers are, what's the percentage of punctual customers according to their originally planned customer journey. And just for getting this type of data, you need to run a lot through different departments, etc. So I think that we talk a lot about the fear of the technology, as well as the silo thinking coming together to prevent people from matching all of this data for the costs. Getting this big picture view is difficult for a lot of departments, especially when you're sitting in operations. You think of the operations costs. There are many costs afterwards that you might not even consider or see. And a lot of the data only exists much later than when the event is happening, talking about compensation costs, for example. So you will only receive the actual data, how many people try to get the compensation, how much was paid out, maybe half a year after the event happened. So matching this data so far, to my knowledge, maybe some airline was able to do it, I haven't seen a full coverage of all costs so far.
I'd like to add to that is if we think about the factors that can drive the solution to an IROPS problem, we might come up with 40 or 50 factors, and for any given event, any one of them can be the dominant factor or completely irrelevant. And I don't know of any way to predict that in advance. So that's another element of complexity that adds into this.
Yeah, and I would just add that the FAA and NASA have for many years trying to come up with, characterizing days and trying to figure out how does the weather and the situation around the country impact airline schedules, and they've been having a very difficult time trying to even just categorize, what are the 7 classical types of days so they can actually plan something in response to that. So it's very hard.
I'd like to add one further comment, though, and I think that you can't predict the exact timing of the weather, as I was saying earlier, but I think that a potential area for future work is in predicting the degradation of flow rates based on past historical data into an airport, and this could correlate nicely to whether individual flights are likely to require diversion or not.
Right, but from a control theory point of view, sorry for being a nerd here, the point that Michael made about being able to, you have to have the dynamics, you have to be able to respond quickly, you have to be able to upscale and downscale your airline quickly to be able to respond. Otherwise, you can predict, but if you're running on an open loop control, it's really hard.
Yeah, and just to add to that, it already started raining, but it was supposed to be this afternoon. But I think to your point, Mike, we have so much historical data that we can predict the effect versus the cause. What I mean by that is I see a lot of researchers trying to predict weather in order to do disruption management work. You're wasting your time. No offense. It's better to predict that the airport capacity is going to be reduced by 50%. I don't care why. It could be a security breach. It could be a thunderstorm. It could be a freak sandstorm. It doesn't matter. We have enough historical data, day of week, time of year, seasonality to predict how an airport capacity will vary based on scheduling constraints, based on maintenance. So we're not predicting if the aircraft is going to break. We're not predicting if it's going to rain. We're not predicting that there's going to be some idiot with a security breach. What we're predicting is the airport's capacity is going to be reduced. So I think it's better for us to spend time using our historical data to predict the effect than the cause. I live in South Florida. I don't believe any hurricane forecast. They say they were going to have 19 hurricanes this summer. We may have them, who knows? But I don't plan until I see the hurricane over the Bahamas. That's when I start putting up the shutters, because it's not an easy task, right? So that still is a key thing that we have to consider in all of this.
Agree.
And let me just to add to that, again, let us look over the fence. If you look at what maintenance is currently doing with predictive maintenance, they are predicting not the failure of a certain part, they are predicting the time frame, which means when engines get hotter and hotter and hotter, you have an indicator to look at it, to evaluate, to simulate, and find out what you're going to do. And this I think we should do in ops as well. It does not mean that we need to predict the time when the thunderstorm hits. We need to see when the likelihood is going higher and higher, that we can start simulations and actions taken. And doing that, I think we could do ways better irregularity management, and if we really have action-based costing.
Another question, please, for Janine Varfas. Could solution suggested by LH Systems, separated decision-making until the production, really have advantage in specializing lower number of people in really advanced troubleshooting?
I would say it is still under development, so things will evolve. What I really believe what is very important is that everybody is engaged in these new technologies now. My experience looking back, I really was sometimes hoping with clients you can do the revolution and you just jump ahead and you change from the old car to the new sports car. If you're not used to a new sports car, it's very difficult to drive it. You need to take people on board. I think we are not there yet, what we could do with predictive and prescriptive analytics. There's a lot we need to do, but if you're not engaged, if you not start thinking about it, if you do not get your data quality right, if you do not rethink of cause-effect analysis, if you do not start analyzing your data and knowing your data, and getting the experience in, same with machine learning, for example, it will be very difficult to catch up or very, very costly. So I would say we need to go ahead now to get engaged, and it will make a difference definitely in the next 5 to 10 years.
The next question is directed to everyone on the panel and asks, is there a way to overcome the challenge of having little or limited financial information that airlines face when programming disruption management tools?
I think there have been some airlines already out there. KLM and Boston Consulting started to work on it, to go into activity-based costing and to develop the solutions. Lufthansa in the Hub Control Center and Operations Control Center started doing that as well. And I believe it is easy to be done. Yeah, you can do it.
I think that one way to approach that whole issue is what, in fact, I developed in the Texas Instruments system back in 1987, which was if you don't know exactly what the different things cost, still you can predict the different effects. And so essentially in developing recovery scenarios, giving the user the ability to balance them versus each other. Each scenario is going to produce so many delay minutes, so many cancellations, so many illegal crews, so many misconnected passengers. And even if you don't have sufficient understanding of what the costs are, if you can provide that level of decision support in scenario management, then you still give the ability to provide a good solution. And in any case, each airline has a different view based on whether it's an LCC or a legacy carrier or a ULCC. They each have a different view as to which of those factors from a marketing and strategic standpoint are more important. And so they are going to use their own judgment in that regard, regardless of the costs of their business related to their business strategy. That's also the same approach that's taken by Boeing Jeppeson's ops control system.
So
Yeah, I
I
mean,
will add to this
go ahead, Jean-Paul.
that knowing is not a 0-1 variable. It's not binary, right? Knowing is not I know or I don't know. Knowing is actually a distribution. If you don't have, you may not know the value of a particular parameter, but you know that it's within a certain bound, and you know there's a certain range, and you know what it can be. And this goes back to the point I was making earlier in my 2 minutes, which is we have a really hard time dealing with uncertainty. And you know, the fact is that there are truisms about information theory, as Michael was saying about, and Mike and Mike were saying, having an aggregate prediction of what's going to happen as opposed to the individual cause, always better. It's always higher probability that you can do that than figuring out an individual cause. Knowing a boundary or distribution about certain things of what could happen can allow you to actually think about what are the set of options or what are the things that I can do that will cover or help me in a range of situations. We have to get away from this. I know exactly what everything is going to happen, and I'm going to run it through an optimizer. I'm going to run it through my brain and tell you exactly what to do. That's not how the world works. We live in a world where everything in life is a multi-stage stochastic program. And we have to start thinking about how we plan and how we do our operations in that way. And we have to think, I may not know the exact value, but I know it's going to be between X1 and X2. And if that's the case, these 3 things I can do now will help me deal with that range of situations. And I think that's where we need to be thinking about, and as we do everything.
I mean, one thing I would add is, you know, there is a lot of challenges in understanding the overall financials. I mean, you know, we've used the word extensively, cost, you know, over the course of the panel conversation. But based on my, you know, I've been out of academia for a few years now and working in industry, and based on 10K filings, based on just working with different airlines, it is straightforward. I won't use the word easy, but it is straightforward to establish real cost in terms of hourly costs. We know how much we're paying credit to our crew members. The soft costs are the challenge. I definitely agree with Mike in terms of what is the cost of a delay, what is the cost of goodwill. And we have found ways to circumvent that, because if you go to an airline, regardless of whether or not they're going to argue if it's, you know, $35.50 versus $45 in each, the key thing is an airline can tell you from 1 to 100 which are your most important markets. Forget about forget about the unit. Just tell me what are your most important markets that you want to protect, and we can use that as a proxy. The most ironic thing about the profitability or the financial objective of developing a solution for a customer is that the one department that is the most resistant in any airline that I have worked with, from an ultra low cost carrier to a full service flagship carrier, is, can I get your true revenue data to have the complete equation of how I make a decision about recovery? Because recovery is not about minimizing the incremental costs. Recovery is about maximizing profit, because that's what your planning department did in the first place. So if you really want to do effective disruption management, you have to maximize profit. But the revenue department is the one department that refuses to give you the true numbers. Even if you're on an NDA, I'm like, what am I going to do with the number? But we're just trying to, and I've sat in meetings where I see ops guys arguing at revenue departments to get these numbers, and I'm like, you know, we want it to benefit the airline. We're not trying to do anything else with it. So that's what I find to be the most ironic thing about the so I want to change the paradigm to not just a cost point. It's the financial side of disruption management, which I think is really interesting. At least that's been my experience.
I'd like to add it. I think this is a generally solvable problem. And I'm glad to hear Mike and others say that the financial part is important. That's one element of the team. You need a multidisciplinary team. You need someone like us, all of us attending here, that has a big picture look at the systemic impacts of all the things that happen. You need an ops controller type who can tell you what the possible tools and solutions, well, solutions particularly, might look like. And you need the financial perspective on what's the impact on the entire corporation, not just now, but in the future, where you look at that element we've called goodwill or the lost future business is, as I said, the elephant in the room that is driving a lot of the factors. So get a team, multidisciplinary team together. I think this is a solvable problem.
A question directed to all of the panelists now. COVID-19 gives airlines a chance to reinvent themselves. Is this an opportunity to make a big shift while there is still a lot of spare capacity to absorb the mistakes? Anna?
Yeah, I'll take that one. For me, yes, it could be an opportunity, but what I think is important that we keep in mind is it's not really the case that we have so much spare capacity everywhere now. I mean, yes, of course, the aircrafts are there, but talking about staff, slots, etc., things change because of the new rules that we have to live with. Talking, for example, just simply airport at the gates, you will need much more space for one flight with much more stuff to cover it than you did before. So the capacity is not really as big as we would think when we look at the overall picture. But of course, this now gave us the chance to have a break and to actually try to find a way to use this time to get a fresh start. A greenfield approach would be great. But I think from my personal experience, in reality, it will not really come to a lot of airlines reinventing themselves due to the current issues they will have with the ramp up again. That will make it much more difficult to cope with the current capacities.
Something I'd like to add to that is I agree with everything Anna said, but also right now, every airline that I talk to has frozen all capital expenditures for at least the rest of this year, and also look at all the airlines that have gone bankrupt in Latin America. We have two of the three biggest carriers have gone into U.S. Chapter 11 style bankruptcy, which means that the stock value goes to zero, and the debt burden is shifted enormously. Look in the U.S., airlines that have gone out of business, like Miami Air, is completely gone now. Others, look at Europe, look all over the world. So it would be great if people could use this as an opportunity to leap forward, but that costs money that isn't there.
I mean, I think there'll be a couple of immediate changes from an operational standpoint. And one thing I think airlines are going to retrench to relying more on their alliance partners. And I think there will be a re-emergence of that old concept of interlining, because airlines are not going to be in a position to operate everywhere. The demand will just won't be there. And one of the things that I brought up on James's talk on Monday is that I see and I believe that there is going to be an increase in multi-leg and the traditional international aircraft routing of multi-leg milk runs, triangular flights, circular flights. And there's going to be the necessary regulatory negotiation for that to happen. And just from a pure domestic operations, I see an opportunity, especially with the increase in the required turn time. Yes, as James said on Monday, the turn time is fine because there's so much less people boarding. The extra time it's taken to clean the aircraft balances everything out. But as demand comes back and there's still a need to have an extended turn time to clean the aircraft, what I believe may happen is that there may be a growing practice of virtual spares versus physical spares, because that provides more slack in the operations for you to clean the aircraft. So instead of having a dedicated spare aircraft sitting on the ground, you're going to run an aircraft with extended turn times and it becomes a virtual spare where it can then be deep cleaned and then be ready for rotation in the afternoon, versus just one aircraft running all day and one sitting on the ground. So I think airlines are going to have to fundamentally change. Aircraft are expensive. I don't work for Boeing or Airbus. We have folks that work for Boeing and Airbus, but one thing I know, that aircraft are not cheap pieces of material, right? So airlines are not going to go out and buy an extra 5 planes because they have to increase their turn time. But they're going to, what I think they will have to end up doing is fundamentally changing and looking at how they schedule their aircraft, how they route their aircraft, and how they manage the rotations in terms of being able to clean the aircraft. Because until the traveling public is comfortable, you know, when 9/11 happened in the US and we saw people at the airport in these blue uniforms with guns under their slots, and everything goes through X-ray, the comfort level, and around the world, that established around the world, comfort level came back and everybody traveled. It's going to take a lot for me to believe that an aircraft, interior of an aircraft, is not. The airlines are doing a great job cleaning the aircraft, but there's still people coming on the aircraft that are not doing a great job cleaning what they're bringing on the aircraft. So no matter what the airline does, the aircraft is still going to get contaminated while you get on the aircraft, right? So until we figure out that bigger picture, there's going to be a need for airlines to change how they operate to survive. Or if not, we're going to have even more bankruptcies.
So I will add to that, you know, one of the things that we have to think about is how do we, you know, when the track, trace, isolate, or inform, either way you want to call it, airlines are in a unique position because even, I mean, on one hand, aviation is a backbone of the global economy, or one of the backbones if you have multiple backbones, but it's also a huge vector for transmitting diseases. I mean, and we saw that in this pandemic, and we've seen that before. Transportation in general is a vector but we have PNRs, and we have basically the ability to see who was on which flight and which staff member were working. And so from an operational perspective, we need to put into place those mechanisms for track, trace, and identify. And that's going to be something I think we're going to have to put in place going forward in our operations. And then the other thing that we need to think about is, can we get more effective testing prior to leaving the airport, for the airport, arriving at the airport, so that we can actually, you know, cauterize or limit the spread of diseases, viruses, etc., going forward. Because I think that's going to be a part of our operations going forward. We need to start thinking now from an operational perspective how we put those into play.
Well, maybe one more thing to add. I think we really need to reinvent what we are doing at the moment. I really believe that sustainability, green environment, and biodiversity will be definitely something on the agenda of a lot of people traveling. Rethinking these type of services and how we can provide a more sustainable airline, that is definitely one thing what I think will be needed to change. On the other side, we will not have, if this crisis continues and we do not find a vaccination, we will need to do whatever you have all mentioned so far. However, this will bring us into an area where we do not earn enough money, which means people need to collaborate. And there has been collaborations before. I worked for Berlin, which was the airline serving the western part of Berlin, and it was a joint venture between Air France and Lufthansa, competitors. Okay, it was then elaborated later, and it was shut down after everybody was able to fly to West Berlin. But any crisis creates solutions. I believe in joint ventures. Take Amadeus. It was airlines creating this reservation system, which is now one of the great big reservation systems in the market. And I really believe that our industry should look into collaboration. Find a partner, work with the partner, find somebody who is helping you in operations control, and to find solutions jointly. I think this is one of the things we need to look at in the future.
Right now, it's about 33 minutes after the hour. Do we have time for any more questions? I've got one more for you.
Let's call this the last one then.
All right. This one is directed to Michael Irrgang, and it says Clark, but it does not indicate which of the Clarks. So I'll read the question and let you decide. Disruptions such as aircraft failure is not a big issue currently because of extra availability. What are the biggest disruptions that can arise in the current scenario for which we do not, or for which we can do a novel research by building an optimizer?
Well, I believe, as I stated at the beginning of all this, that the biggest disruptions are when you have major diversions, in particular from thunderstorms. The two biggest causes of diversions are going to be either fog or thunderstorms. Fog is a lot more predictable for a given airport. It's when it's shut down by fog, you've got a lot of history. It's going to be closed in the morning and open up after a few hours. What's the definition of few? Well, who knows, but you know when it starts. Thunderstorms, the issue is, are they going to move through in what time frame? And 15 minutes makes all the difference in the world. I personally believe that the time is right, and this in fact I'll call this my closing statement. I think the time is right for what both Michael Clark and myself referred to, is using the vast amounts of data that we collected to start focusing on effects and cause rather than the causes. Focus on what is the effect and come up with solutions that work to focus on the predictive nature of those effects and the ability to work around those effects. I think the time is right to do that. I haven't seen that there are systems on the market that can do that yet. I have a few ideas, but I think that's where our focus should be and where we can come up with good optimization solutions. Michael?
Sure. I mean, immediate right now, June, I forgot what day it's June 3rd. The one thing that I think can be a major disruption in the airline network or in the global airline networks, I'm even thinking beyond an individual airline. Just hear me out for a minute. Things start to open back up, and even before COVID-19, airlines were pressed with, and within an airline alliance, I'm going to reroute my passenger over a particular country, and they don't have a transit visa, and that's not an option. Or a particular crew member, based on their passport, is not allowed to go into a particular country because of geopolitical reasons. As airlines open back up and countries open back up, and God forbid the second wave of COVID comes in, just as James mentioned on Monday, countries are going to open and close at their will, right? So it's going to be a disruption, right? So you have everything planned, everybody's booked, the flight's about to leave, and the whole country's like, we're closed. What do you do with all these passengers that maybe transit in that country to go somewhere else? How do I in real time reaccommodate those passengers? So you have the aircraft, you have tons of aircraft. The aircraft doesn't have to have a immunity or a visa to go to the country. It just has to have the operating certificate that it does, right? Or the permission for that type rating to fly to that country. But the disruption is that because of the second wave or because of something new, the country our region shuts down on such short notice, that your operations just totally goes out of whack, what do you do? Do you just say, I mean, just think about how airlines dealt with the, I mean, just think about how airlines dealt with the implosion of the world for COVID in terms of people being stuck and having to be repatriated. Countries had to negotiate flights. Some people are still stuck in some countries. Even now, they still not able to see their loved ones. But just think about, so what have we learned from that? We have to figure out, if that happens, could we develop a new network that adapts to these dynamic changes? I mean, that's the extreme, right? But that's just an example of what I see the future of. So it goes to Mike's point that yes, you have something happening that's localized, but if you imagine this happening, like, no, I can't go on a business trip. It makes no sense for me to go for a one-day meeting, to go to the United Kingdom, to quarantine in a hotel for 14 days, to go to a one-day meeting, to come back to the US and quarantine for 14 days. That's 1 month for a one-day meeting. That makes no sense, right? So, if dependent, and I think Indigo talked about that yesterday, even within the states, within India, so forget about my example of the world. Just look at what Indigo is experiencing in India, right? It's like they have the plane boarded and they're going to Gujarat, or they're going to some state, and all of a sudden the particular individual state says, no, we're not accepting anybody from this state. What do? Everybody from this state, get off the plane. We can only take these 10 people. I mean, that is going to be a really, I mean, I know it's a short-term phenomenon, but it could become a long-term reality if something else happens, or God forbid, COVID comes back sooner before we have a vaccine for it. So, I mean, that's like an immediate thought process. I mean, just thinking beyond the weather, because the weather is always there.
So that concludes this panel discussion. Just a couple of last comments. First of all, I'd like to thank all of my fellow panel members. Each of you brings similar but very different backgrounds and viewpoints to the party here. As I mentioned earlier, this is the first time we've really done a panel in the AGIFORS study group conferences. But, and as I also mentioned, on Friday, we will do the usual poll of all the conference delegates, asking a number of questions. One thing that I'm very interested in finding out is whether the audience as a whole is interested in the future in seeing more panel discussions. You're going to see another panel on Thursday of airline operations people exclusively. And please think about this. If this is a regular change we should make going forward to the AGIFORS Airline Operations Study Group. So thank you very much, everyone. And now I'll turn things over to